micrometers are going to give me a more advanced reading. Now what we can see here, we have the flat head. Now this one is going to be more suitable to reading the thickness of a flat surface like a sheet. Now this can give you the micrometers reading. For example, what will be the thickness of the paper, just paper or the flat sheet or whatever the thing is. And this will be just simply by putting the contact between both. Some of them have an edge here, and this one can be used to check what will be the thickness of the gap. Okay, now the other type of the micrometer we have is the needle head. Now the needle head is going to be very useful to read the diameters of the gear. When I say diameters, because every gear is going to have multiple diameters. It have the diameter between the inside the teeth, and we have the one at the top, and of course we can do some calculation to check what will be the radial diameters of the gear, what we call the pitch radial. So to do that, we're using the needle shape. Of course, it can do the same thing with the threaded part. It can check what will be the internal diameter of the threaded part. So if I would like to check this one, by the way, I can set this value to 0, and it's going to give me the analog reading. And again, this should be calibrated because I don't think it's going to be set to 0. We need to work very carefully with this device because the extra forces on the needles may break it. Now it does have an error of 2 in 1,000 of millimeter, and we can simply consider that as a constant error. Okay, now I think that we can calibrate that manually. Nope, that's just a lock. Okay, anyway, it's needed calibrated by sending the things to Motoyoto, which the manufacturer, and we can do the calibration for that. Now I can take off this one. I need to put it back in the box as soon as I can. So let me fix this one first, and then I get to take the other micrometer, clean it, and put it back in the box. Okay, just to clean the thing, and be sure it's going to be turned off by itself. I'm going to turn it off. No, I just changed the unit, but this should be on and off. Anyway, I'll try to turn it off before we leave the lab. Now I'm going to do the measurement with this one. So the main thing is to put the gear bottom value, because we have the peak and the bottom, between the needles. You need to go to the maximum. Yep. Okay, so just put the thing in the best location here. Okay, now the reading we have here is going to be for the diameter, which is 24.89. That's what I can see in the readings here. Okay, so once again, the needle head is going to be used to check what the diameters of the threaded parts or the gear diameters. Of course, we have a larger version of this device sitting at the corner there, and we have a laser one, and a more advanced one also can be found, which can use the ultrasound. Now I can take all this one, put it back in the box after I clean it, and we're going to go to the other type, which can check what will be the thicknesses of the slotted part. Now we are going to show you what do I mean by the slotted part, or the gap, small gaps. The slot is a cut, channel cut we have on the parts. It's not like that. So this one is a slot. It does have a thickness, and the best way to measure the thickness of this one is using this type of the micrometers. So this micrometer, as you can see, have two discs moving upward and downward. Okay, and we can simply put it here and open it by rotating the part. Again, I need to do that on the table. Okay, so we put it, the two sides should be put in, and I'm going to open the thing until I'm going to have some resistance. Then I just passed that, because actually, as I told you, I'm single eyes now, and it's actually going to be too difficult to see the things by using the first man shooter thing. Okay. Yep. And then we can take the readings, what will be the diameter of, the thickness of this slot. And the reading for this one is actually starting from the right to the left instead of the left to the right. Okay, starting from the right to the left. Opposite for the others, we're starting from the right to the, from the left to the right. Now, simply because this one is going to be open and closed, and this device will go to the left when the value, or the gap is going to be closed here, as you can see here. Okay, this one is to check what will be the thickness of the slots. Now, the other types of the calibers we have in the front of us is this one, which is called the go, no-go gauge. For this one, it's something similar to the first time when if you remember, when I put the part, I set the 0 at the 4 millimeters or the 5 millimeters, and I said, okay, now when I'm going to measure the parts one after the other, if I'm going to have larger value, that's mean my diameter is larger than what's required, and if it's going to be smaller, that means the diameter is going to, or the thickness is going to be smaller than what's required. Now, to easy things and make the process of the measurement much faster during the manufacturing process, when we're going to have multiple parts, and I'm going to set what will be the actual value, the required value of the thickness, and what will be the maximum and the minimum, which what you call the tolerances. Now, for the tolerances, this one was 20.036. So, for example, I can say that the diameter, the thickness I would like to make is going to be 20 plus 0.05 minus 0.05. That means that the maximum thickness I would like to have is going to be 20.05, and the minimum thickness I would like to get is going to be 19.95. So to do the fast measurement for the parts is I'm going to set the smaller one, the inner one, to the minimum diameter. So this one is going to be 19.95. The upper one is going to be 20.05. So for the ease of the measurement, just get the part and slide it in. So it should pass from the first one. That means that the maximum thickness is less than the 20.0, equal to or less than the 20.05, and it shouldn't pass through the last one. That means that the minimum thickness is equal to or more than the 19.05. So that's what we go, the go, no-go gauge. So it's go first.